Hello again. Tonight we're going to look at generating equivalent fractions part 2, which is going to include simplest form and mixed numbers. Go ahead and take out your note sheet for this lesson, or print one if you don't have it. Our unit goal is still about how you can demonstrate what you know about fractions and decimals by reasoning about their value. Only in this lesson, we're going to use models multiplication and division to show fraction equivalence. Yesterday, we learned how to make equivalent fractions by taking pieces and making more of them, using models and multiplication. Today, we're going to show how to make equivalent fractions by combining pieces. Let's take a look at this example. In this picture, I see 9/12. If I take those 9/12 and combine pieces, grouping 3 pieces together, I can see that instead of 9/12, I can in fact have 3/4, showing me that 9/12 is equal to 3/4. To use simplest form means that a fraction is represented by as few equal parts as possible. You can use division to find equivalent fractions and even simplest form. Let's try this example. I see the fraction 2/10. Yesterday we learned to use multiplication and take that fraction 2/10 and split them into more pieces, say by multiplying by 2, to get an equivalent fraction of 4/20. But instead of multiplying into smaller pieces, I can divide and make the pieces larger. If I have 2/10, since both numbers are even, I can divide by 2. And 2 divided by 2 is 1. 10 divided by 2 is 5. So 2/10 is equal to 1/5. Since 1/5 shows me a fraction that cannot be represented in any fewer parts, it would be in simplest form. Let's take a look at this example. In this example, my model shows more than one whole. In this case, I have a mixed number. What is a mixed number? A mixed number represents more than one whole with part of a whole. I can see in this model one complete whole, a second complete whole, and then 3 out of 5 pieces, giving me 2 wholes and 3/5. If I wanted to shade that same amount on this other model, I would still have to shade in 2 whole models, and then an equivalent fraction for 3/5. With my shading, I still have 2 wholes. But in this case, my pieces are no longer in fifths, they've been changed to tenths. So I now have 2 wholes and 6/10. Notice that the whole number does not change, but the fraction does. And in this case, it did so using multiplication. 5 times 2 is 10, and 3 times 2 is 6. Let's try this example with the mixed number. First, look at the one shaded in green. What fraction do you see? Did you say 4 and 5/10? Now look at this next example on your page. What would you shade in to show that same amount? Did you shade in 4 wholes and 1/2? If so, great job. In this problem, equivalence was found using division. The whole number 4 still stayed, but the fraction again changed to show 10 divided by 5 is 2, and 5 divided by 5 is 1. 4 and 5/10 is equal to 4½. Mixed numbers can also be written as a fraction greater than 1. A fraction greater than 1 is any fraction with a numerator that is bigger than the denominator. Fractions greater than 1 can also be shown as mixed numbers. Your parents would call these improper fractions. I see 3 wholes and then 4 out of 12 pieces. So I have the mixed number of 3 and 4/12. To write that as a fraction greater than 1 or an improper fraction, I write how many total slices I have. The denominator is still 12 because there are only 12 slices in a whole. Only I have 12, another 12, which makes 24, a third 12, which makes 36, and then 4 more, which makes 40 slices, or 40/12. I can express this as a mixed number in thirds as well. I can shade in my fraction to show the equivalent. The shaded fraction still shows me 3 wholes, but it shows me 1/3. To write that as a fraction greater than 1, the denominator stays thirds, since the whole is represented by 3, but I in fact have 10 slices of thirds for 10/3. This can be found using division, just like our other equivalent fractions. 12 divided by 4 is 3, and 40 divided by 4 is 10. Take a look at these examples. You have them on your paper. Are these fractions equivalent? If I have 9/12, I have to do 12 divided by 4 to get 3. Is 9 divided by 4 1? It's not. That makes these fractions not equivalent. What about equivalent mixed numbers? 5 and 2/5 equal to 5 and 6, what? The wholes are the same, but the fraction is not. 2 slices have become 6 slices. 2 times 3 is 6. 5 times 3 is 15, showing me that 5 and 2/5 is equal to 5 and 6/15. What about this example with the fraction greater than 1? 21/4 is equal to 63 over something. 23 times 3 is 63. What's 4 times 3? Did you find 12? Great job. What about that last part? Can you make an equivalent fraction using division? What number can divide into both 6 and 8? Did you say 2? 6 divided by 2 is 3. And 8 divided by 2 is 4, showing me that 3/4 is equivalent to 6/8. How are you doing? We've done a lot with generating equations. It's time for you to complete the check for this lesson. Remember to write down the questions from the check on your notes and bring them to class. We'll start by reviewing these problems first and practicing particularly with mixed numbers and fractions greater than 1. If you want to go back and review the problems, replay this video to check out your work. Have a good night.